Good afternoon, everyone. My name is Evangelina Shreve, and I'm the Director of STEM Education at Pacific Northwest National Laboratory. And I am a member of the Executive Committee for the C2QA Workforce Development Team. Welcome, and thank you for joining us. Today's panel will cover pursuing a graduate degree and a career path in quantum and how to differentiate yourself. I am very excited about the incredible group of panelists that we have joining us today to discuss today's topic. I would like each of them to take about 5 minutes to introduce themselves, what organization they represent, and if they can share a little bit about their own career in quantum. So I'll start with Tina.
Hi there. So I'm Tina Brower Thomas, and I have a bachelor's degree in chemistry from Howard University and a master's in chemistry and PhD in materials chemistry from the NYU Tandon School of Engineering. I also did a postdoc. I was an NRC fellow at the Naval Research Lab. And I think one of the things I want to say is I've really appreciated our speaker before, Dr. Lewandowski, because she gave some great statistics. So I'm going to talk about what I do, but I want to make a point that as a double minority, I'm really passionate about research, but also workforce development. And a lot of those different areas that are quantum fields and engineering and physics and so forth also happen to be the areas where you have the least number of women who have degrees in those areas. So I think it's really important that that I represent women who pursue STEM and are into quantum. So I am the education director, the PI at Howard, and the executive director at Howard for the Center of Integrated Quantum Materials. I'm also a part of the Co-Design Center for Quantum Advantage, which is sponsoring this. And I volunteer in the workforce development and outreach for that effort. And I'm also a materials researcher. And finally, I'm with the Center of Quantum Networks, where I am also diversity director, a co-diversity director, and I do research. And, you know, obviously many hats, but when you're passionate about things, you just find a way to get it done, which I hope that I'm speaking to an audience of folks who are, because you're here, that means you're passionate about science and about STEM. And so we're glad to have you, and particularly about quantum. I just want to say that I came to quantum in a really circuitous way. In undergrad, I did polymer research. And then in graduate school, I started off as a polymer chemist. And I decided that although when I was young, I really liked mixing things together. And my mom sort of encouraged that by getting me a chemistry set. So I would stop like taking her cleaning supplies and almost blowing up the house. So I was encouraged early in synthetic organic chemistry. I spent my summers as a youngster doing theater, singing, dancing in the daytime in the summers, but in the evenings or late afternoons and evenings, I was in a pharmaceutical lab because my mom worked in the College of Pharmacy at Howard University. So I got an early exposure to mixing things up. But I discovered that I really didn't like the harsh chemicals that were involved in polymer. And I started to understand some of the environmental impacts. So I started to look for another area of research that still sparked my interest. And when I was an undergrad, I was and studied organic chemistry in particular. I loved pi systems, which are a way of describing carbon atoms, the electrons in carbon atoms and how they move about. And I always found that fascinating. So I moved into, we didn't call it quantum. It was kind of quantum because it involved tunneling of electrons. But we were at that point just thinking about quantum in terms of not so much taking advantage of the quantum properties, but just the understanding of quantum to look at technology. Now we're understanding more about the properties itself and how they could be used for quantum engineering. But anyway, so I basically got into pi systems. I'm still with pi systems, and it's through pi systems that I have flowed. I think that's hilarious, but anyway, I have flowed into quantum, working at two-dimensional materials. I started in graphene, which is, in my view, a wonderful, beautiful connection of pi electrons. So that's my story.
Thank you so much, Tina. That's a great, rich background. Thanks for sharing. Jenny Hoffman.
Can you hear me?
Yes, we
Yep.
can.
Okay,
Thank you.
thank you. Well, Tina sure is a tough act to follow. She is so articulate and has such a rich story. But I am a professor of physics and applied physics at Harvard University. And I started off as an undergraduate here and then did a PhD at Berkeley and a postdoc at Stanford, and was lucky enough to return as a faculty member here. So my former professors are now my colleagues. Which is, an adjustment. But I've been here on the faculty for 16 years, and I study quantum materials. I use molecular beam epitaxy to synthesize materials, so to grow materials one atomic layer at a time. And then my primary focus is on building electron microscopes to actually visualize those materials at the atomic level, really see individual atoms. And I love what I do because it's something of a marriage of science, the technical, the mathematical, the quantitative, logical problem solving thinking. And also because it's microscopy, it's sort of an art form. There's a lot of visual pattern recognition, and how do we create images of these materials that allow us to kind of get some visual intuition about what is going on at the electron level in these materials. So I really enjoy that synthesis of science and visual beauty. And I would say that, so I'm also here on this panel. I'm on the chairing the graduate admissions committee in physics and in our Harvard's new quantum science and engineering program, which is launching for the first time this year. And I have served on graduate admissions committees for 16 years at several different universities and several different departments at Harvard. So I have a lot of insight into how that process works. And I'm very eager to recruit a diverse group of students into this year's applicant pool and to matriculate in our new quantum science and engineering program at Harvard. And would like to emphasize the importance of communication skills in bringing together this very interdisciplinary field that is quantum, that's really at the intersection of physics, computer science, chemistry, applied mathematics. And when we bring all these disciplines together to address this goal of quantum, it requires really excellent communication skills and really thoughtful ways of interacting with people who come from very different backgrounds than ourselves. So I look forward to sharing answers to any questions you may have throughout this panel.
Thank you, Jenny. That's already great insight for our students. We're very excited to hear more about the inside tips that you can offer our students as they apply to graduate school. Also, the next person I'd like to introduce himself is Jeffrey.
Hello, everyone. It's a pleasure to be here. My name is Jeff Thompson. I'm a professor of electrical engineering at Princeton University. I've been here for about 5 years. Prior to coming here, I did my undergraduate degree at Yale in physics, and then a PhD also in physics at Harvard. Actually, I worked in a lab just down the hall from Jenny's labs, and then a postdoc at MIT. So I'm in electrical engineering department now. I see myself as a physicist, and I see myself as still doing physics work, and I'll talk about that in a minute. But it is actually interesting to me to be in an engineering department now, because historically, actually, the way I really got into physics was, being very interested in tinkering and building stuff as a younger person, and realizing at some point that science and in particular physics offers kind of unrivaled opportunities to go and build just new and crazy things, and all in what you might call the real world. You can go and engineer neat stuff, but it's got to work, and it's got to fill some application that is motivated by profit or being useful or something like that. And in physics and in science, we can kind of discard all of that and come up with just a lot of really quirky and weird reasons to try to build really neat and interesting stuff of a kind that nobody's ever built before. One of those things being quantum computers. This is what I work on now. So my own research, I'm by training, I'm an atomic physicist. And so the kind of bread and butter techniques that we use are things like laser cooling and trapping and manipulating atoms in ultra high vacuum chambers. And my group does that stuff, as well as a lot of stuff with kind of micro and nanophotonic devices to try to make, physical platforms with which we can do basic, operations in the space of quantum networking and quantum computing, which are two really important areas of quantum technology. And let me conclude by saying, like Jenny, that I've also spent a lot of time in the last 5 years on graduate admissions committee, thinking a lot about graduate admissions. How students can convey their strengths, well to us, thinking about how we look at applications, what reflects, attributes that the students that we'd like to admit. So I'd be very happy to offer some advice on that as well. That's all I have to say.
Thank you, Jeffrey. Next, if we can have Heather introduce herself.
Hey everyone, my name is Heather Saunders and I work at IBM in the quantum organization. I started my career as a computer engineering and Japanese major at the University of Pittsburgh. So that's where I got my undergrad. And then I actually went to Duke University for graduate school where I got my master's. I have a slightly different path because while I was a PhD student at Duke, I ultimately decided that research was not my passion and went into industry. So I have a little bit of different experience there and would be more than happy to talk about those differences and my career. So I started at IBM as a software tester. That was about 7 years ago. And I've worked a number of different jobs at IBM since then in software test, as a test lead, and then also in project management, a little bit of communications before starting with the quantum team, where I worked first as a community manager and helped manage the internship program at IBM Quantum before transitioning over to a software management role. So hopefully I can give a little bit of perspective on, what is it like to be in the quantum field as an engineer, as a computer scientist? What are we looking at in industry? How can you get into working for a company like IBM rather than in the academic world, or straddle both? We have a lot of really excellent partnerships with academia here at IBM. And I think that there's a lot of opportunity regardless of what your background is and where you're coming from to get into quantum. That's one of the things that I really like about it, is I get to work with tons of really smart people that have really different backgrounds across all different industries and specialties. And I love being able to pull all of that together and see it come to fruition. So I'm very happy to be here with all of you today.
We're very excited to hear more from you, Heather, as well, because we do have a great deal of students who are interested in pursuing quantum information sciences, but they're not interested in going the research route. So thank you for joining our panel today. And I believe we have our final panelist. I'd like to introduce himself, David.
All right. Thank you. I'm Dave Biersack, and I'm like Heather, I'm coming more from a corporate or non-research track. My background is I graduated from the United States Military Academy at West Point, and was stationed in Germany right as the Berlin Wall came down. And after going to Iraq, I went to the Naval Postgraduate School to get my degree in some interesting technologies, voice recognition for the F-14 Tomcat, and some satellite counter reconnaissance, which we called fuzzy logic at the time, and now it's called machine learning. After the military, Microsoft recruited me. I worked for Microsoft for many years and got great exposure to working with large groups of developers. And then Pfizer called and was starting up a drug discovery group of PK/PD modeling, large scale, multi, 1,000 compute grids for pediatric oncology. And that was a really wonderful experience. My background was in math and physics, and we got to do a lot of simulation and modeling. And then about 10 years ago, I decided to get back into the service of our country. And I joined Brookhaven Lab as a technology architect, which is a great job because every day I get to work side by side with scientists in every field: chemistry, physics, biology, earth science. And I help them with their computing problems. So I'm more of a scientist trapped in the body of a computer scientist, but it's been great to work with them. A lot of scientists have some very advanced models, and they're sometimes struggling how to get it to work most efficiently on computers. And that's where I come in. And my journey into quantum started really from an education perspective, because working with a lot of interns, I take interns every summer, and working in a lot of classes on scientific computing, I've realized that it's hard for certainly undergrads to get their toe on the ground with quantum computing. And so I helped develop C2QA's first quantum workforce summer school workshop for undergraduates and graduates in quantum computing. And right now I'm doing a lot with quantum machine learning. So I'm more on the application side, the software side of quantum, but it's been a great experience so far. And, you know, having some military background and working in corporate America, Microsoft, Pfizer, and coming to the lab, and I'd be glad to answer any questions you might have. So thank you.
Thank you so much, David. And I hope that many of your students from this summer's boot camp joined us today. I know everybody has busy fall schedules, which, by the way, happy fall to everyone. Today is the first day of fall, so a great way to kick it off. Did I miss any of the panel? I think I got everybody introduced. Great. Panelists, I welcome you to unmute and interrupt me at any time. The most rich opportunity that these audience can get is hearing your stories, your background, your experiences, much like you've given us a little bit of a view in your introduction. That is so valuable for our students. So thank you everyone for the introductions and insight into your careers. Before we begin with the series of questions that our panelists will address, I want the audience to know that you can put any questions you like for our panelists in the chat box. We would like to monitor those questions and we will address as we can. This is a great opportunity for you to get the wisdom of this great group of diverse professionals. So I encourage you to ask questions. I will now start with a series of questions and call upon a panelist to address. Panelists, feel free to let me know if there's a particular question you'd like to address and I haven't called on you. So we'll get started here and hopefully I can manage the questions at the same time. Let's see, let's start off with how transferable are general software engineering and computing science skills in the field of quantum computing? And what sorts of internships can I get in quantum computing as a software developer? David, do you want to start with that one? Feel free to punt to another panelist.
I think Heather certainly can provide some insight. I do know that the general skills that you learn as you acquire quantum programming skills are super applicable across so many different domains. So even if you haven't yet maybe perhaps developed a lot of quantum skills, if you had some interest or passion in learning scientific computing, once you harness those skills, then picking up and being able to apply them in a quantum computing situation is very transferable. So it's certainly not the case that if you spend a lot of time acquiring quantum skills that is, you know, you're going to be locked into that niche. Those skills are so transferable, you know, because you're dealing with visualization and large scale data analysis. It's really a great synergy there.
Thank you, David. Heather, would you like to follow up?
Yeah, sure. One of the things that IBM Quantum is known for is our full stack approach to quantum computing. And we hire a lot of software engineering, computer engineering, electrical engineering interns, as well as full-time employees in the quantum organization and outside of IBM, I mean, outside of quantum and IBM. And as David said, those fundamental software engineering skills are very transferable to what we're trying to do with quantum. You know, we're not only trying to build quantum computers, we're trying to make those quantum computers usable by companies, you know, whether that's over the cloud. So we need people with experience in cloud architecture and hybrid cloud, and how do you manage services? How is our performance going to look when we have 1 billion circuits running in a day, right? So there's all kinds of general computing concepts that extend into quantum at companies like IBM, and I suspect the same is true at other large companies like Amazon, Microsoft, Google. Anyone that's trying to take quantum and really make it something that's available beyond the physics world. You know, we want it to not just be experimentalists using quantum, but how can we actually apply quantum in the real world? And to do that, we need tons of computer science and engineering students and practitioners to help us make that happen. And so I would say very transferable, and absolutely now is the right time to ask those questions. You know, if you're a computer science student, you're interested in quantum, look at, you know, what is that niche? Where can I apply my skills, and where in the software stack does that apply, and kind of look for positions there.
Excellent. Thank you so much. How about if I'm interested in getting more research experience as an undergrad, and I'm interested in pursuing a research career path? What are some insights that you can give to me? Can we start with Jeffrey?
Yeah, you can just call me Jeff. Yeah, well, I think that so you're interested in research as a career. I mean, I think, certainly an important part of learning how to do research is doing research. So at many universities, there's opportunities to get involved in faculty research. Even in a research group, even very early on, in your career. And I guess some there's a kind of a decision you have to make about how you do that as you go through your career, which is that you can either hop around and sample a lot of different things and say, I want to see what this kind of research is like, I want to see what this kind of research is like, or you can try to get very deep into one particular project, and work in the same group, on the same project for several years. And there's benefits to both. In one case, you get to experience a lot of different things. In another case, you have the opportunity to get more done in the end. Even as professional researchers, I can say that I have a tension between approaching, projects one way or the other myself. But I do think that some amount of depth is important. At the end of the day, the what you do, what you understand about a research, I mean, even if you don't solve a problem, what you even understand about the nature of the problem when you first get started is just a tiny sliver of what you understand after you've grappled with it for a long time. So I do think that by the end of your undergraduate career, getting some amount of, trying to aim for at least some amount of depth in at least one research project is pretty important.
May I add to that? I think Jeff was spot on. As education director and some of my other roles, part of what I do is offers undergraduates opportunities to have research experiences. And those research experiences can vary from an REU that's just 10 weeks to programs where you can go back year after year and work with the same person or work within the same research support with another group. And so it is important to have some sense of what you really like to do. But I agree that depth is necessary. But one thing that I would say in distinguishing yourself, which going back to what we want to focus on, is that make sure whatever you do, you can get a good letter of recommendation from the person that you work with, because that goes a long way when you're considering either graduate school or an industry job or government job. So, I think that's a very important point.
Thank you so much, Tina.
Yeah, I'll just chime in with one other note as well. There are a number of programs out there that pair academic research with industry research as well. So one example is the IBM and Princeton have partnered up with the QRIP program, which stands for Quantum Undergraduate Research at IBM and Princeton. Very, straightforward acronym there. But that gives you an opportunity to see a little bit about, do you like the style of academic research? Do you like the style of industry research? Get some of both under your belt while working sort of within the same field. So keep an eye out for programs like that as well.
Thank you so much for that addition, Heather. I know there was a question about the C2QA Quantum Information Sciences Bootcamp this summer. So we provided that information on the chat for the audience. Dr. Hoffman, can you tell us a little bit about why your institution decided to develop a PhD degree in quantum, and how is that different from a degree in physics or applied physics or even computing science? And is Harvard's PhD available for students interested in quantum information sciences, quantum materials, and or quantum devices? That's a long question.
Yeah, sure. Well, I think the first part of that is probably the most important. Why did we decide to launch a new graduate program? We've long had a traditional physics, computer science, chemistry departments. Why do we need a new program? And I think the answer is that quantum is really at the intersection of several of these different departments. And there may be a student who has a computer science undergraduate degree or has some software skills and is used to thinking in binary bits, but is interested in the idea of taking those computing skills into the quantum realm and thinking about qubits. And so they may have a very strong background in algorithms and programming and not have the background in the physical quantum mechanics. Or vice versa, there might be a student who has a very strong quantum mechanical or mathematical background and just doesn't have the practical software programming skills, right? So there's a lot of students who come in with very strong backgrounds, but don't have the full puzzle in place to address that interdisciplinary, that intersection that is quantum. And so this new program really provides an opportunity with an interdisciplinary admissions committee who's going to be looking at students with the admissions committee is going to have many different areas of expertise among the faculty and the committee, and is going to be able to find the best students, even if they're very strong in one area and not necessarily educated yet in a different area that's essential to quantum. So I think bringing together this interdisciplinary group of faculty is really important for finding the most talented and diverse, both intellectually diverse and humanly diverse students in this space. And then from the educational standpoint, we recognize that we have to develop a program to bring students up to speed. In their traditional undergraduate programs, they're probably really expert in one area, but not necessarily expert in the other area. So we need to develop courses that can bring all of these students together to a level playing field so that they can be expert in this quantum intersection between the traditional departments. And then I think the third point of developing a new program is to develop a community scaffolding for this group of students. And again, I want to emphasize how important it is when we have traditional subfields who are used to speaking kind of different languages, using different notations, and we're bringing them all together to have good communication skills, to be able to cross these barriers. If I use this notation, I use this notation, I use this vocabulary. And so providing a community structure in a program with a uniform laboratory rotation system, uniform advising and mentoring system, retreats where everybody can give talks on their research and get coaching on their communication skills. That's all really important to advance this interdisciplinary field, to have this kind of uniform scaffolding for mentorship and communication. Yeah.
Yeah, I just want to add, if you'll notice that across the board, from Research One institutions to public high-level research institutions, many programs are being stood up. And so I would encourage those who are interested to simply Google. In my area, George Mason University, University of Maryland, Howard has some curriculum that they offer, but just in my area, that's two very different schools, but they both see the necessity for developing some kind of programming in quantum, whether it's a certificate program or an actual degree. So,
as a follow-up to Jeff, Tina, and Jenny in particular, what if I'm a student and I'm very interested in quantum, and I'm an undergraduate and my school doesn't have good advisement from my academic advisor on what courses I should be taking to help me be a well-rounded individual to be considered for a graduate program that is focused on quantum? Any recommendations for that? Do you want to start, Jeff?
Well, I believe Jenny has the only graduate program focused in quantum, in the United States that I know of right now. So.
Well, I think, so this is our first year of this new quantum program. So we as an admissions committee are also going to be learning through this process. But I think that we are expecting that students are going to come in with a more single disciplinary traditional education in a traditional department. So we are not expecting that everybody is coming with their own personal quantum guidance counselor. So, if you can demonstrate your ability, your communication skills in your traditional department, and then use your communication skills to describe why you're interested in this interdisciplinary field. And I think Tina alluded also to, like, Google is your friend. You can find information on the web about cutting edge quantum developments. There are some excellent popular science journals, Read Wired magazine, and understand what is at the forefront, what are the goals, and articulate why you want to take your traditional single disciplinary background and move into this interdisciplinary space. That's great. We're really looking for good communication skills in order to be at this interface.
Great, thank you. Pivoting a little bit on the industry part, Heather, what would you say would be the top, so I'm a student as an undergrad, I'm looking at graduate school. We always need to keep our eye on, establishing our journey from an experience perspective, an academic perspective, with an ultimate goal to have a professional career doing this work. What would you say are the top soft skills that would differentiate me when it comes to industry?
That's a great question. And I think really what we're often looking for, communication was mentioned because it's such an interdisciplinary field. There are a lot of different languages that are spoken, and being able to work with a wide variety of people from a lot of different backgrounds is really important. We realize as an industry, especially for a large team like IBM Quantum, we have pretty lofty goals in terms of where we want to take quantum. And we know that that's not going to be a one-person effort. We know that it's going to take hundreds of individuals working on teams. So we really look for teamwork, and that could be working in another internship, it could be other internship experience, that could be leading clubs, whatever you're passionate about. It could be things like open source contributions or giving talks, that kind of communication skills, and also leadership skills. So what we are looking for is people who are passionate about things. And I think all of those skills, find what sort of makes you tick and find a way to get involved with other people doing that, and get involved in organizing clubs, in attending, different seminars and things like that, and show that you're willing to sort of go beyond and reach out to other people and work together on that. Because that's ultimately an industry, you're never really doing your own thing. You're always working as part of a team. And so you're always expected to be able to work with other people, report your status back up line, whether that's to your manager or even higher above, as well as to share the insights that you've gained with other teams. So those kinds of communication and leadership skills are really important.
Thank you very much. David, do you have any addition to that?
Maybe not so much on the soft skills, although everything Heather said is exactly right, especially the ability to get along with a diverse group of people. But I would just maybe take a little tangent. And again, mileage varies. Everyone has their own opinion, but from a hard skills perspective, I guess, at least in my experience working with the interns I've had and the types of asks from scientists to me to help them in their quantum analysis is math skills.
Mm-hmm.
Everyone, it's not the most popular topic and people want to shy away from it, but while you're an undergrad, to the degree that you can really get a firm foundation on core math, linear algebra, things that are the fundamentals of quantum, I would say that will position you well for in grad school. Maybe not, you don't have to go way esoteric on the math courses, but you really want to make sure you know the foundations well, because time and time again, being good at those core Lego blocks is really what will allow you to assemble anything. So I would encourage that, don't turn a blind eye here towards really shoring up your math foundations.
Thank you. Any other comments to that? So how do I go about finding more experience internships, especially at national laboratories? Where do I go? How do I begin to identify internships at national laboratories per se, if I'm interested in research? David or Tina?
I'll let David go first.
Okay, yeah, and that's a great question. And the Department of Energy has this Science Undergraduate Lab Internship SULI program, which is tremendous. It's available at most of the national labs across the country. And every year we have hundreds of possible internships. And it is competitive, but I think it's a great opportunity, and you should really take a look at that. We can put in the chat the link, at least, to BNL's thing, and then the Department of Energy has a SULI site as well. And I really encourage, every year I try to encourage more and more undergrads to apply to these internships. And we also have a graduate research internship program. So that's, there's no substitute for getting that kind of experience. So don't sell yourself short. Don't, think that you just can't, you're not competitive. Please apply. We'll try very hard to find a good match for you, because we really enjoy and celebrate your passion.
So I would just, thank you, David. I would just add, there are a few basic areas to look. The government labs, whether that's DoD or DOE, as David mentioned, but also there are some industry opportunities. And in terms of academia, that's sort of where I fit in. And I would say that I recruit from two-year colleges. I recruit from minority serving institutions, and I recruit from Ivy League institutions. And in that process, I look at passion is obviously background, right? So there's some, if I have to match with a professor that is interested in taking on a student, they have to feel comfortable that that student is prepared. But not every student is going to be equally prepared, especially if you look at the vast array of places that I'm choosing for students. But that's where passion comes in and interest. So if someone is interested in doing research, and I can see that they have done some steps beyond just filling out the application, they actually maybe research some of the professors that might be involved, or research what the government labs are interested in, and try to speak to that. Going back to communication skills, that would be more of a written communication skill, but somehow you have to really convince in your application that this is really something you want to at least try, or you have a real passion about, and help the person reviewing the application be able to make a case for you. And I think if you can do that, even if you go through the process of filling out the application and going through those steps, let's say you don't get an internship, you've done the first step, because sometimes it's just like making sure you do things on time and making sure you know how to write a letter of interest and all those skills. So just jump in and do the process, see where you go, get relationships with your professors. They often can be a good vouch for your potential. So that's important, because a lot of people ask, well, I've never had a research experience. How do I get my first research experience? That may start with doing really well in your class, in a course, and communicating with your professors and letting them know your interest so that they could support your application.
Thank you. And in the chat box, we have provided more information about National Laboratory internship opportunities. So feel free to explore that to learn more about National Laboratory internships. And as David mentioned, all the National Laboratories offer internship opportunities. So don't just go to your nearest National Laboratory, look across the nation at the 17 National Laboratories and what opportunities might be there for you. It seems to, based on some of the comments that you all shared, that really having a network, including faculty as part of your network, is key. So it seems like it would be good to find a mentor. What would be your recommendation in finding a good mentor? Tina, do you want to?
I want to jump in. I don't want to monopolize the conversation. So I think the first step is you have to be, I think, you have to be willing to be a bit humble and recognize that you have somewhere you want to go and you don't know how to get there. Once you acknowledge that, then I think when you start talking to people about that's in your circle, you never know where that can take you. So the first thing, I think you have to be a little bit vulnerable about the fact that, yeah, I want to do this, I'm not sure how to do it. And the more you start letting people know that and asking people for advice, you'll eventually find the right person. But certainly you could also look at, if you kind of know what your interests are, you have a general idea, you can look at who's doing what you want to do or something close to it. And see if you can reach out and introduce yourself. Again, I think Jenny makes a good point about communication skills. So those communication skills come to play there as well. And you can also ask, let's say you're in high school or, in college, you can also ask your professors and your teachers, this is what I'm interested in. Can you help me figure out how to get there? Do you know anyone that might be able to help me? It gets a little bit more, it has to be a little bit more crystallized, I would say, when you're in an undergrad situation. I think relationships with your professors, again, are key. A lot of professors have, they're getting funding from government agencies, and a lot of those fundings require education outreach efforts. And so they're actually looking a lot of times for students to work in their labs. So you can also look at your school and say, who's funded? Who has NSF funding, for example? And once you figure that out, you can say, knock, knock, I think you need me just like I need you.
That's great. Jenny and Jeff, any insight from the faculty perspective on how a student can identify a good faculty mentor, for example?
Yeah, I wanted to chip in also. Thanks, Tina, for starting the answer. But I think that there can be a bit of a romantic view about mentorship. Like, I'm going to meet my match and it's going to be like my Prince Charming or, whatever, that's my perfect mentor who's going to satisfy every single need that I have. And I'm not sure that that's realistic. In fact, there's a lot of actual research in psychology, in the School of Education, in the School of Business, that says that it's not necessarily realistic to expect one human being to satisfy both your professional advice needs, your psychosocial needs, your all of the various questions that you're going to have as a student. And so I put together, I don't know if you guys can everybody see the chat? If I just pop something in the chat. Okay. So so here's a map, which I have adapted shamelessly from the National Center for Faculty Diversity and Development, that shows how you can take ownership of this mentorship process and really think about the different functionalities that you need from a mentor. You need somebody to advocate for you. You need somebody to maybe protect you in case there's adverse forces or politics in your department. You need somebody to provide you with the resources, whether that's lab equipment or funding or recommendation letters. You need somebody to teach you the skills. You need an intellectual community to get you excited and bounce ideas off of. You need somebody who's going to give you substantive, constructive criticism on your work. You need the soft skills, the professional development, the communication. You need maybe somebody who's going to provide you with accountability. I mean, that could be your mom, right? It could be somebody who calls you every other day and says, hey, did you do X? Did you meet this deadline? It could be your best friend. So I think it's important to go through a map like this and identify different people who can fill these roles, but it doesn't necessarily need to be one Prince Charming who fills every single one of these roles.
Yeah, I totally agree. I think I was just trying to, like, how do you get started? I think what Jenny's laid out is not only how do you get started, but how do you evaluate that they could be a good mentor? And a lot of universities offer mentorship training for faculty. And I think, and also for postdocs that, may be working with you in research. So I think it's also important to make sure that the person that you choose, if that's a faculty person, is interested in being trained, or I don't like to use that word so much, but is not just signing up for something and they have not looked into what does it really take to be a good mentor. And so if they've actually looked into resources like Jenny's mentioned, that's a good indicator that they actually could be a mentor that would work for you.
Thank you. That's all excellent advice. Jeff, did you have any addition?
Yeah, I agree with everything that Tina and Jenny said before me. And actually, Jenny, this map that you linked to is very interesting, actually. But let me also just add that in the context of trying to, cultivate a relationship or find a research group to work in with a faculty member, at your university, or a summer internship at another university, the one thing that I would keep in mind is that you're asking something from this person to commit some time and some space and maybe some equipment in their lab, and at very, how much of those resources are available from that person and their environment fluctuates over time. So there may be cases where you ask somebody, would you think you would be a really good fit, and you might actually be a really good fit, but at just that particular point in time, there's just not a way to make it work, and I think you have to move on. But it's also okay to be persistent and take a not now, as an invitation to come back later. I do think, as I've watched students, here try to find a research group they can work in. One strategy that I think works well for people is, ask somebody that from a class or because they gave a seminar or something like that, if you can work in their lab. But then if they don't have space, ask them to suggest some other labs, because that's a good way to generate. I may know that somebody historically has had a lot of undergrads in their lab and does quantum related stuff or stuff that's adjacent to it that maybe you don't know about. So just ask faculty for other suggestions if they're unable to host you in their own labs at that particular point in time.
I'm sorry, if I could just add one thing to that is Jeff brought up a good point. You also have to really consider how large the group is. So you have to be careful about that. So, if you know in yourself that you're not a person, you need more one-on-one, for example, you don't want to necessarily go to a research group that has a gazillion undergrads and like one grad student and one postdoc or something like that. And I really appreciate it when I've had faculty say, I'd love to, but this is not a good time. That's a faculty that I'm going to go back to and ask again, because that tells me that faculty is really considering the big picture and how things work together and wants to invest. And if they can't invest, they're going to tell me no. And that, I don't like to hear no, but when it's right, it's good to hear no.
I also just wanted to add a slightly different perspective there, I guess, from the working with scientists at the National Lab. I'm in their office as they're going through applicants, trying to decide what interns they're going to take on. And, there's a certain, I guess, truth that, the scientists say, I have a lot of work on my plate. I have funding, I have deadlines. I need an intern that I can't, not only that I teach, but is actually going to help me. And I get that. But then when I talk to the undergrads, I also hear them self-select out, saying that, well, how can I possibly help this person? I don't know anything about this. And, I try to bridge the gap by saying that, there's always some level of basic data science or computer help that the scientists need. They have a lot of information to get through, a lot of data. They need to visualize it, analyze it, classify it. And I think an undergrad that can show up having some credible skills in scientific computing or computer science to help them, that's at a very base level, at least, that's the way that you can help them. You can provide value. You can add value as an undergrad to an advanced research team, even if it's just taking on some of what you might consider to be the more menial data science jobs. But, don't think to yourself as an undergrad that how can I add value? Because a lot of the mid-career scientists, they really do need help with computing. And if you can come up with those skills, I think you will add value. So please don't self-select out and say that there's nothing I can offer. There's a middle ground here where you can help the scientists who need the help, and along the way, then get access to a great research team and a great mentor.
Excellent comments. Thank you very much. So really emphasizing that identifying a good mentor is not only about finding somebody who can help you with your academic and professional, but it's a mutually beneficial relationship. And so there's an opportunity that you can help that particular faculty member, researcher, or industry leader. And often just by being involved in that mutually beneficial relationship, you have exposure to maybe things and experiences that you have not had before. Excellent question, and great comments by the panelists. I wanted to remind everyone that some of the panelists are responding to questions in the question and answer chat. Thank you. I know there was a really great question about how do you distinguish yourself in IBM internship applications, which Heather has provided an answer for. I encourage those of you who are searching for internships to read that. I also encourage you to read Jenny's post on the mentor map and information, and then many other informations that are being shared in the chat. So if not now, at the end of the panel, I encourage all our attendees to review that. Just kind of switching back to an academic question. We have a student who is just completing their undergraduate degree and recognizes there's often quite a gap between the undergraduate knowledge and the ability to read and understand the scientific literature critically, perhaps more notably in the theoretical fields. While applying for graduate admissions, what level of familiarity is usually expected of an undergraduate student? And that student having worked with understanding the work that's been done by the faculty from that school. Can our academic partners respond to that?
Sorry, is this question, are the questions available in writing for us to see anywhere? That I didn't absorb all of that in real time. Where can we see the questions?
Yes, it's a long question and it's in the chat. It's the only one left unanswered. So if you, I think Jeff was going to start the response, but feel free to review it, Tina, Jeff, and Jenny.
Yeah, I was actually going to ask you to repeat the question. So
Question, but a good one.
yeah.
I think, so for example, the Center for Integrated Quantum Materials has a YouTube channel, and many centers have their own, websites and YouTube channels where they have seminars available. And oftentimes, you can actually, let's say, there is a professor that you want to work with, for example. If you Google that professor, you probably could find somewhere where they've given a lecture, or the topic area. If you Google the topic area, you might find some lectures from someone in a center that might help you understand, help you bridge that gap. And I'm not on the admissions. I think I'll punt to Jenny a little bit on this one, but I don't think that they're expecting you to understand every single thing, right? So, you're applying for graduate school. You're not a graduate student. You're not a postdoc. So I would say give yourself a little slack on that. But there is a lot of information out there in terms of recorded lectures, like this is being recorded, for example, that can really help you understand some of that gap that you're thinking about.
Yeah, let me add to that and say that I think that that looking at lectures and research papers from groups is a great idea to get kind of acquainted with the different types of research that are going on in a department that you might be applying to, or in a field that you're thinking about going into. But I would really see that as educating yourself on the decision to go into this field. From the admission side, at least when I look at admissions, for our department, I'm actually not primarily interested in, like Tina said, how much you know about the research that I'm doing. The thing that I'm looking really closely at and thinking really critically about is whether you understand very well the research that you've already been doing. That's the thing where I think you really need to demonstrate, oh, I did this project, I worked in this lab for a year and a half. What I'm going to be really critically interested in is how well you understand the contours of that field. What are the interesting questions in that field? How the specific work you did relates to the goals of that field, not whether it's connected to the field that I'm working in, but just that you really have a level of maturity and sophistication about the research you've already done.
Any additional comments, Jenny?
I just want to echo that. I think that, oh, I'm sorry, Tina.
No, just quickly, not just the research, but also the academic platform that you've demonstrated. A lot of people are like, okay, how do I get into quantum? Well, how well have you grasped classical, right? And the quantum you've had on top of that, if that's available to you, that's great. But just, if you can also not just research, but your academic background, if you can help that come across, I think that's also important.
I wanted to echo what Jeff said, that I think it's more important that your research statement can demonstrate your expertise in what you've already done, because if you don't demonstrate mastery of what you've already done, then how are you going to master new things? So I really think that's the most important point. But if you have the bandwidth to go a step beyond that, I think it can be really useful to look for PhD theses, because the intro chapter of a PhD thesis is often a really good entree that describes things in the pedagogical language that you're going to need to get started. And, some of that is by intention. I think a lot of PIs tell their students when they're graduating, like the most important function of the PhD thesis is to provide the manual for the incoming graduate students. I mean, the results chapters, those are already published and peer reviewed. Who cares about those? The most important contribution of your PhD thesis is your intro chapter that's going to provide the on-ramp for the next generation of students. So if you do have the extra bandwidth, if you've already demonstrated a clear understanding of the research you've done, and you have the extra bandwidth to go a step further, see if you can track down a PhD thesis from the lab that you're interested in joining.
Excellent advice. Thank you so much.
Actually, maybe let me take the opportunity to synthesize everything that we've said together and tell you, actually, we actually do have an internal kind of rubric that we use informally or actually maybe a little more formally now.
This is what we wanted to hear. This is what I was hoping to get to. Thank you.
And it's got 4 boxes that we kind of evaluate separately. One is, academic performance. It's basically, did you excel academically in whatever you were doing? You could get a perfect, well, you probably couldn't get a perfect score with an English major for our department, but with some, but it basically, did you excel at whatever you did? The second is, do we have any evidence that you were, were interested in and excelled at research? And here we want to know about whatever research you did. We're going to try to evaluate that on its own terms. The third point is whether your interests, as you state them, are aligned with the kinds of things that go on in our department. And when we think about that, we're not usually talking about, okay, this person says they want to do quantum, but I don't think they know what a qubit is. We're not usually having those kinds of conversations. It's more like, this person says they want to do driverless cars and we don't do driverless cars. We have actually a lot of people now who do driverless cars in our department, but something like that. And then the fourth thing is that for international students, we think critically about English skills. So really, those are the 4 categories that we think about. And that fifth one about how much do your research interests align with ours is it's not one that we really spend a lot of time thinking about. It's not the most important one. So I would think more about those first 2 and English if you're an international student.
Great. Thank you so much. Thank you for wrapping that up and being very specific. That's the secret sauce right there, students in the audience. Really focus on that rubric that was summarizing all of that input. Moving a little bit away from the research side and looking at a question where a student says they love the undergraduate classes that they're in that introduce them to quantum, but they don't know if they want to do research. And so but I do want to pursue graduate school and I'm interested in quantum. Is that possible? And I think this speaks more to David, the application that you talked about. So maybe David and Heather, if you can respond to that.
I'm trying to understand the actual question, sorry.
So the question is, I'm an undergraduate student. I have been introduced to quantum. I really am interested and excited about it. However, I don't know if I'm interested in taking a research career path. So, what should I do as I consider pursuing graduate school?
I guess I would divorce whether or not are you interested in research and versus quantum. That's a more of a heartfelt question. I don't know. I guess I don't have a clear answer for that. They would have to understand what do they hope to achieve by doing peer research? What do you see as your end goal?
So I'm sorry, when I get questions like that, the first thing I ask is, what do you think research is?
Right.
Because that to me sounds like a person who doesn't really understand. They have in their mind what research is, but they don't really know. So they haven't had the exposure to how broad that term really is. So I think the person would have to ask themselves, what do I think that means in terms of what research is? And then I'm not exactly sure where you go from there, because that will depend on what background and what the interests are. Because, some people like theoretical, but they think research means that they have to tinker in the lab, and they don't want to tinker in the lab. They'd rather be behind a computer or write some code or something more along those lines. So I think that person has to really start with broaden their understanding of what research could be.
I think on the flip side too, if you have done some undergraduate research, you are getting into kind of understanding, well, what does it really look like to be a PhD student, to be doing your own research and, figuring out, well, here, what are the questions that I want to ask? And then how do I answer those questions and all of that? If that's something that doesn't interest you, then yeah, it really depends on your field, and I have personal experience in that area of, I actually did do undergraduate research and really enjoyed being a part of research projects and a part of a team. But when I got to the PhD level, what I didn't enjoy was starting with sort of, it was almost too broad, like too much of a blank slate for me. I liked working on a team and working towards a goal with other people. And it depends on your program, it depends on your group, so you almost kind of like, I'm really glad I went to grad school and sort of went for it. And tried it out and then got to decide, okay, I don't think this is where I want to take my career. But, and as an engineer, I knew that I did not need a PhD if I didn't want to do research or I didn't want to teach. As an engineer, a master's, perfectly fine to sort of go into industry and be successful, so I think a lot of it, you just kind of have to determine, like you said, well, what is research? What is it that you want to do? What are the things that you enjoy doing and don't enjoy doing? And then kind of figure out and talk to people in those fields, talk to people who are graduate students, who are professors, who are working in industry, and say, what is the balance of your work look like? How much time do you spend on these pieces and parts that you do and don't like, and kind of get a feel for, where do you want to go from there? Because I think you can absolutely be successful in quantum, especially, in computer science and engineering. Maybe not so much in the physics area, it kind of depends on, again, where in quantum you want to be and what you want to do, but you can be successful without a PhD, without a graduate degree. So figuring out where is your passion, you'll find sort of paths to success that way as well.
I think that answer will help the student because it really is about finding your passion. And to Tina's point, in some cases, as undergraduate students, we didn't know even what research meant, right? There's different levels of research that lead to different outcomes. And Heather, I think you sharing your own journey helps students, right? Because it's an evolution process. So thank you all for sharing and responding to that. We do have a couple of specific follow-up questions, and I know Jenny is going to have to leave a few minutes early to attend to a class. So I want to, this question is specifically for her. And thank you for sharing the skills you are looking for with students. Could you elaborate a bit more on how you're expecting students to demonstrate their communication skills? Is it about past experience in giving presentations, for example, or just working in a collaborative environment?
I think the simplest way to demonstrate your communication skills is by writing a good research statement, right? So we, as the admissions committee, we're looking at what's in front of us. And if you can write a good research statement that shows that you have good technical communication skills, that's a huge benefit to your application. And I would put in a warning that, a lot of this at a practical level, a lot of universities use some generic graduate admissions software that has some generic prompt that says, tell us your personal statement. And then, a lot of people, when you're an undergraduate, you wrote your personal statement for college and it was like, oh, I have these relationships with these people and I had this personal growth. And by the way, I play tennis and, so the personal statement labeled as such in your graduate application is not really a personal statement. It's a research statement. So you should use it as an opportunity to showcase your research and technical writing skills. And you can put figures with captions. You can put references. Try to make it as much like a proposal or a paper or a sort of grown-up piece of scientific writing as you can. And that's going to be demonstrating your communication skills. And of course, if you have leadership that you have demonstrated through other activities, put that on your CV and make that clear to the admissions committee as well.
Great. I think this conversation has spurred a lot of conversation and specific questions about application to graduate school, GPAs. And so if our academic partners can look at the question and answer chat and see if there's any answers we can provide the audience, that would be great. Tina, did you have a follow-up to that? Did I miss a cue?
Well, I thought that, I thought that was a pretty concise answer. I did have a thought, but I got distracted by looking at trying to answer the question.
Sorry,
If
I
it comes
did that
back to
to
me,
you.
I'll let you.
Right.
I'll
Yes.
let you know.
Okay, so here's a good general question following that response by Jenny. We understand that, you know, communication skills, and I think that's some great insight about distinguishing what your research, you know, space is right in the application process. That's just some great advice. There's also
I'm sorry. Sorry. I was going to say recommendation letters should back up your great communication skills. So I think that's what I was going to say. Yeah. So if you have, written a paper, or, that you then put in the application as Jenny described parts of it, or if you have given a talk, if you could find someone that writes a recommendation that could speak to how well you do that, I think that would be good also. Sorry.
No,
Yeah.
Great addition. Is there any, there's a tactical question about, do certificates such as edX or courses matter at the time of admission? David?
I would say yes. You're trying to mount evidence for consistent commitment to either a particular field or just developing yourself technically. I can't speak in the college setting, although I had gone through that when I was their age. But I know when we're looking at the national lab, when we're looking at who we want to take on, not as interns and even as graduate research students, every little bit helps. I mean, it's showing a consistent determination because we know science is mostly failure and people get turned off by failure, and we need people with grit. And if you can show that you're attending these events and succeeding, we want to know about it. So I would say yes.
Thank you.
As a counterpoint, let me say that I can't recall an admissions case from the last 5 years where I noted that somebody had taken one of those courses, which is sort of the opposite answer, but just my experience.
Yeah, and that could be on the two different paths, right? Where you're going straight into applying for jobs versus research graduate schools. Heather, did you have an additional comment?
Yeah, I was going to say, I think that the places where I've noted those on applications are places where you're learning something that might not be offered at your school, right? So it could be something like we have a Qiskit developer certification at IBM, for example, that's available. And those kinds of certifications where we know that quantum computing is not ubiquitous yet in schools. And so those kinds of courses that you might take online that are giving you background experiences that you may not get as through a typical class, that we might note. But otherwise, taking an edX linear algebra course versus a regular course, more often we would expect to see it as part of your regular curriculum. So I wouldn't say that that would necessarily tilt one way or the other.
I think also how it's weaved in is important. So if you are making a case for why you're the candidate and writing in your application, somehow weaving in these courses for whatever reason that you took, I think that could be more of a standout than just having it listed on your, somewhere in your application.
Right. It's definitely the courses, as Heather said, that are, you had to go beyond your current load. You really pushed yourself. It carries a lot of weight with us because the students, their schedules are already so packed, they can barely squeeze in anything extra. But if they're willing to make a sacrifice and attend these, like the summer course we did this in quantum, the students had to, they gave up 4 weeks of their summer, and but they were willing to do that, and that carries a lot of weight.
Great. As a follow-up question, are there any major skills or experiences that can set post-bachelors apart when applying for jobs in the quantum space?
This is a really interesting question. And it's interesting because, when Jeff was talking about how the fit was the less important piece of a graduate application, I think from an industry perspective, at least from an IBM perspective, the fit is often one of the more important pieces that we're looking at, right? And we're really looking at do the skills and experiences that you as an applicant have line up with what we need as a business to move forward? So we are a little bit less flexible sometimes on that fit, because we know that you have those skills and experiences for a reason. That's what you're passionate about. That's what you're interested in. So we want to put you in a job where you can exercise those skills. And so you might have amazing skills in an area that we're not looking for, and then that may not be a great fit. And that, doesn't necessarily mean that you're not a good applicant. It just may mean that we may not have the position at that time to really satisfy what you would enjoy or need as, from a career perspective. And I think part of that is because, it's, again, you're a little bit more established at that point of like, here's what you're interested in, here's what you're doing. And once you get into a job, it can be a little bit harder to sort of switch gears. Not impossible, and I've done it many times at IBM, but it can take a little longer. So we actually really do look at fit, and we look for what sets you apart, what makes you unique. And that's different for everybody, because we look for so many different things. We look for researchers, we look for computer scientists, we look for hardware engineers, all over the place. You can really just, and I mentioned this in one of my text responses, write down what is it that makes you tick, what is unique. Are you really into open source software and you've made a bunch of contributions, or have you done really interesting niche research in an area that might be related to what we're doing? And when we find somebody that has those skill sets, that's really what's going to set you apart. So
Thank you. That's a great advice. Just a little bit more general of a question. A student wants to know, how much time should they invest before they know that quantum is the best career option for them?
Oh,
any comments or recommendations on that?
I'm still answering that question for myself.
I guess I have an answer, and I'm going to have to leave soon, so maybe I'll jump in first, and then I got to pop out because I have to teach at 3. So I think that maybe several decades ago, people would enter career and stay there for their entire career. And I think that in today's workforce economy, the fast-paced reality, people are changing a lot during their life. Maybe you do something for 10 years and then you open the next chapter and you do something else for 10 years. And that's okay. And so I don't know that you ever, we always used to ask, what are you going to do when you grow up? I am not sure that I'm grown up yet. And, I am maybe looking at 2 or 3 more decades of career, and I'm not entirely sure what those are going to be. I know what I'm doing right now, and I'm enjoying it right now. And if I stop enjoying it, at least I'll know that I have built the skill set of communication, of problem solving, of being able to learn new things that is going to enable me to do whatever the next step is. And I think that quantum is a really excellent space in order to build those skills, because you are going to have to build logic skills, quantitative problem solving skills, communication, programming skills. These are all things that are going to be valuable in many different spaces. And, right now there's a lot of investment and interest in quantum. The next crisis might be the climate crisis. That's also going to require an intersection of a lot of different areas of expertise, from sociology to political expertise to technology on many fronts. So I think that building these kind of interdisciplinary skills, like if you're enjoying it now, it's going to prepare you well for the future, whether that future is quantum for 5 years or 10 years or the rest of your life, and then something else beyond.
That's great. That's great. Yep. I think that is a perfect segue to one of our final questions, which you just gave quite a bit of advice. Before you need to leave, Dr. Hoffman, any other #1 piece of advice that you would give to someone hoping to enter the field of quantum computing in graduate level and beyond before you need to leave us today?
Sorry, is the question, do I have any more advice? I might have just exhausted the entire store of all advice that I have.
Great.
I'm not sure. I think I'm done.
More opportunity. Fantastic.
Well, great job, Jenny.
Yes, thank you so much, Jenny. I know you need to leave. So let's just go around the table, starting with Tina. What would be your number one piece of advice to someone hoping to enter the quantum computing information science career path, especially at the graduate level and beyond?
So touche to Jenny, because she said I was a hard act to follow in the beginning, and now I'm going to say she's a hard act to follow towards the end here. I think really having a sense of being excellent at what you're doing, and really following your passion. And a lot of what Jenny said, I just want to piggyback on, because we don't, when I finished my PhD, they weren't calling it quantum. It was the big word was nanotechnology. But I certainly was looking at things on the scale of Planck's constant, right? So I was doing quantum, right? But they're not calling it that. They weren't calling it that then. So they'll be calling it something else, having those transferable skills that are connected to your passion. Really, I think most of us who are in science have a passion for learning and for problem solving, and for understanding how things work. And as long as you take that with you, it really is not going to matter so much what they call it in 5 or 10 years. And you can take those skills to something completely different. There are many stories of scientists who started off in biology and ended up in things more related to agriculture or computer science. So it just, yeah, that's my advice.
Thank you. Jeff, your last piece of advice for our audience?
Well, we're on the topic now of talking about, how to find your career path. And so maybe let me say something else on that topic. I have what I think is maybe a pretty extreme view in this area, which is that, anytime you hear an old person tell a story about their career, a very successful person of a certain age tell a story about their career, how they got started in this, and then they decided that this was really hot, so they moved into that, and then they saw that this is the next big thing coming, so they moved into that. I think that story is, there's a big selection bias there, that basically the old and famous person that you're listening to made a bunch of right choices, probably kind of partly by chance. And I don't really believe that most of us have the ability to actually really truly see what the next thing coming is, to have enough information to make a decision about not only what the next hot thing is, but what even the best thing that you can do with your skills is going to be, because I might think the next big thing is in biology. I might be right, but I can't do that from where I am now. So all of that's to say, I have a little bit of kind of a fatalistic attitude that you sort of, at any point in time, you get some information, but there's no right or wrong answer. Or there is, but you don't know what it is. So that the best thing that you can do
Very
is
quantum.
Yeah, exactly. But you can't do all possible things at the same time. Quantum mechanics would just say do everything and then try to collapse onto the, whatever, the Nobel Prize or something at the end. But if you study quantum algorithms, you learn that that's not actually going to work. So I think that what you can do, you should do. So there's 2 principles that I've used to kind of guide what I do, is that something, the thing you do should be like, it should challenge you, right? You should be doing something that's hard, that's going to push you to learn more. You should, and the second thing is you should do, or related to that, is you should do something that other people you admire the work of are also doing. You want to find a good community to work in. And I said 2, but it's 3. The third one is it should be something that you're actually passionate about and excited about. And there's no rhyme or reason to what you're interested in. But waking up in the morning and being really motivated to do something can make a big difference in terms of how productive you can be at something. And so keep those things in mind.
Nice.
That's great advice. Thank you. Heather, what would be your last piece of advice to our audience today?
Yeah, so I would certainly echo the advice of following something that makes you want to wake up in the morning and go to school or go to work, because I can tell you that slog is going to be a lot longer if you're going to work or school for something that you don't enjoy, right? So, and my other sort of more tag along piece to that is learn how to network. And by networking, I don't necessarily mean, cold calling people, reaching out on LinkedIn. What I mean is take what you're passionate about and find that community that does it. then you will be able to surround yourself with people that know that you can do a good job. And it could be anything, right? Like a lot of my networking originally came from marching band, because I was into marching band, and I met people across the entire university there. And I was able to get advice. I was able to get help when I was interested in something that I wasn't already doing. I knew somebody that did that, and I could go to them and say, hey, how do I get into that? Here at IBM, I am a member of the Toastmasters Club, and I focus on what are some things that I enjoy that can expose me to people that are outside of my team, that are outside of what I'm immediately doing, so that if I do decide one day that I wake up and say, I don't think I want to do this anymore, I'd like to make a change, I'd like to go try something different, I have a little bit of a wider, social or work network of acquaintances that I can go to and say, hey, I heard that you work in quantum, I'm really interested in that. How do I get into that? Or I heard that you work in cloud or blockchain or whatever it is. And that, I think, sets you up to be successful, so that you don't have to have sort of that anxiety of, oh, am I really putting myself in this niche spot? And then I'm going to, end up hating it 5 years down the line. So that's my advice there is, first off, find something you like, and whatever you like doing, find other people that do it that aren't just on your team, so that you can branch out and network and have some of that support system when you are looking for something new.
Great advice. So wake up in the morning and follow your passion. 2, find the people who are like-minded about the passionate work you do. Be adaptable and be willing to challenge yourself and set high expectations. And what else, David, would you add to the last piece of advice that we have today for our audience?
Well, a little bit of encouragement, because I work with interns and they feel overwhelmed. And I remind them that we've been teaching geometry for 3,000 years. We've gotten good at teaching geometry. Maybe I'm just speaking for myself, but I don't know if anyone knows exactly how to teach quantum computing. It's a new field and we're getting better, but don't get discouraged. Everyone wants to see the forest from the trees, but you navigate forests one tree at a time. We all want the jigsaw puzzle box top. You build a puzzle one piece at a time. I really encourage the students to stay sharp on their foundations. Yes, you could be a great computer programmer and not have any clue how a transistor works, but there's some intrinsic value in knowing how it works. And so I encourage my students to stay on top of what they don't know, not to be afraid of it, don't delude themselves. And when they get a chance, to try to dive a little deeper and to build up that foundation. I mean, the greatest buildings are built on very solid stones. So, really, take the time to master the fundamentals, because then the future is yours.
Excellent. Well, thank you so much. I want to share with the panelists that there's been some comments in the chat thanking you all for your honest answers and advice and tidbits of information that can be applied as our audience seeks their own journey in the quantum education and career path. So as you can see by today's discussion, quantum science requires a lot of people with different backgrounds: physicists, electrical engineers, computing scientists, software engineers, chemists, and many more. And it can be overwhelming to consider a career in quantum science and information and pursuing a graduate degree. However, there is a great opportunity in pursuing graduate school and to differentiate yourself in your next steps in your educational endeavor and in your career. So we want to thank you for joining us today and all the great questions. A great thanks to all the panelists today for being with us.